Hey, Chan Physics. So it's Sunday and I'm getting ready for Monday, and just wanted to do a brief video to introduce you to the idea of finding distance in free fall. So remember what at least I've said to my class is that we have been trying to convince you guys that all objects fall at the same rate, and that rate on Earth is negative 9.8 meters per second squared. And I told you that we would do a bunch of experiments and then you guys would forget it. And so the idea is that the weekend is gone and maybe you guys have let your pre misconceptions fall back in and say heavier things fall faster. So, as promised, here is a quick video of the astronauts on Apollo 15 who are going to try the experiment, this time with a hammer and a feather. So, we'll just watch a couple of seconds of it.
Not quite yet. I haven't put the solar landing yet, but I will shortly. I want to watch this. I'll have a good picture there. I've got beautiful. Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. And the feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here and hopefully they'll hit the ground at the same time. How about that? Mr. Galileo was correct.
Okay, so I didn't let that video go much further because after that you'll hear that beeping that's really kind of harsh. But it is one of those things that I always say in my class. It's just absolutely unimaginable that these astronauts, these brave people, went up to the moon. And that beeping that you sound is actually that you're hearing is the sound of the communication systems where they have to let go of a button so that the other side can talk. And that's how, if you think about it, like walkie-talkies, if you ever seen those work. And that's just how simplistic the communication system was, but they still were willing to trust their systems and go to the moon, even though they had to release a button and then there would be a beep to tell the other side, okay, now you can talk. Or then they would release their button and then now you can talk. And so then every now and then when they would try to talk over each other, you'd have that massive beep that would drive us crazy. And so we sit here now, 2020, going, wow, that's really annoying. But the reality was, this is in 1971, and these people are on the moon. And they just conducted that experiment, and the hammer and the feather landed at the same time. Okay, so finding distance. When we find distance, we need to use a little bit more of a complicated equation that we're used to. Okay, and it will take some practice for us to get used to what we're seeing in that equation, but we will be able to find the distance of any object either thrown up or dropped with this very same equation. D equals VIT plus 1/2 AT squared. And just the T is squared. And I probably told my classes this all the time, but it's just the time that's squared. And a lot of the common mistakes in this segment is to square the whole term. So the 1/2 AT, and then they square the whole thing. Just the time is squared. All right, every second the distance increases exponentially, meaning that it's getting faster and faster and faster. So we don't have a very simple equation. Distance means it has fallen that far, but if it's a positive number, that means it's still rising. And if it's a negative number, that means it is now below where we let go. Remember that time is squared. All right, so let's just do a quick example of a problem set. So let me grab my paint and bring it over, and we'll go from there. So here's our question, and our question is, a skydiver has fallen from rest for 6.5 seconds before opening her parachute. What is the distance the skydiver has fallen? So let me get my marker here. We're going to do a 4-column method. Okay, T here is 6.5. Okay. And then everything else is kind of hidden in the words. So we'll just start out with our equation. D equals VI T plus 1/2 AT squared. All right. And when we put that all of that together, we're going to get D equals, well, VI. If the SkyDriver falls from rest, well, then we must have missed it, but VI is 0. So VI is 0, so 0 times 6.5, okay, plus 1/2 negative 9.8. Out of our way. We don't need that much in there. Negative 9.8 times 6.5 squared. All right. Sorry, I had to take a break there. My wife was pounding some chicken, I think, for some meal, so that would be all flat and everything is just going crazy. So anyway, we're right here. 0 times 6.5, this is going to be 0, right? So this is going to be 0 plus 1/2 negative 9.8 times 6.5 squared. And so we'll just make sure that if we want to, we can take a bit of a break and say, well, 1/2 of negative 9.8 is negative 4.9, right? So 1/2 of negative 9.8 is 4.9 times 6.5. And then we'll just square the 6.5 with our calculator to get our distance. All right, that's how simple it is. The main thing is for you to remember, if they ask you for the distance, use the distance equation and make sure you understand what everything is, what all the variables mean, and then you'll plug in the right answer.